The cultivation of food has been an essential part of human history since the first civilizations discovered how to domesticate plants. Over the centuries, various methods have been developed to optimize production, whether through the selection of more resistant seeds or the improvement of irrigation systems. In the current scenario, where the demand for food is growing rapidly and arable land is becoming increasingly contested, innovations are emerging that have the potential to profoundly transform agriculture. One of these innovations is the practice of producing vegetables and other greens in vertical structures, usually installed in urban areas or near major consumption centers. Stay with me so you don't miss any details about this alternative that could help us solve problems like world hunger. In this planting method, entire buildings can function as multi-story farms, replacing the typical horizontality of traditional agriculture with a more compact and technological design. Instead of acres and more acres of soil, there are vertically arranged shelves where plants grow in controlled conditions. In many cases, soil is not used, but rather methods such as hydroponics and aeroponics. The goal is to increase productivity and reduce spaces, save water, minimize the use of pesticides, and optimize the transportation of food to the end consumer. To understand how these farms work, it's important to keep in mind the concept of controlled environment agriculture. In conventional farming, we deal with the uncertainties of weather, excessive sun, sudden storms, intense cold, or disproportionate heat. In a vertical farm, practically everything is measured and adjusted: temperature, air humidity, nutrient levels, and lighting. This allows for greater control over food quality and harvest predictability. In general, producers are able to obtain several crops throughout the year without depending on the seasons. Thus, a more stable model is created that moves away from natural weather adversities. Another fundamental issue is location. In large cities, many people face lines and long commutes to access fresh products, which usually come from rural areas. By installing a vertical farm within or around the metropolis, transportation logistics are reduced and production is brought closer to the end consumer. This proximity tends to reduce food waste, as the time between harvest and consumption is shortened. Products such as leafy greens, sprouts, and aromatic herbs arrive fresher on store shelves or directly on the consumer's table. When we look at the internal structure of a vertical farm, one of the main highlights is the lighting system. In many cases, LED lights are used that can provide exactly the light spectrum plants need for photosynthesis. With this type of lighting, it's possible to adjust the colors and intensity, creating a customized environment for each stage of plant development. Instead of relying on the sun, which varies throughout the day and seasons, specific lights are used to stimulate growth and productivity. In some setups, lighting schedules are even controlled by software that understands the most suitable cycle for each crop. Along with lighting, plant nutrition is also precisely managed. In hydroponic farming, for example, the roots are suspended in a nutrient-rich solution without soil. This allows for meticulous control over what the plant receives, avoiding waste and reducing water usage. In fact, one of the strongest arguments in favor of vertical farms is water efficiency. While conventional agriculture may require massive amounts of water to irrigate fields, hydroponics consumes significantly less since the resource is recirculated and maximized. Moreover, because the water doesn't spread into the soil or evaporate across large surfaces, the loss is much lower. Aeroponics works in a similar way, except that instead of keeping the roots immersed in a solution, they are suspended in the air and receive nutrient sprays at scheduled intervals. In this system, even more water is typically saved, since the liquid not absorbed by the roots can be collected and reused. In both cases, there's the added benefit of reducing the risk of pests and diseases, as the absence of soil and the controlled environment hinder the proliferation of unwanted organisms. As a result, the use of chemical pesticides tends to be much lower, contributing to cleaner and healthier products. Another crucial point in vertical farms is the use of sensors and management software. With devices that measure temperature, humidity, nutrient solution pH, and CO2 concentration, it's possible to quickly adjust growing conditions if something falls outside the ideal range. Many of these systems also include cameras that monitor plant growth, detect potential signs of stress, and send real-time reports to the farmer or a specialized team. In some cases, artificial intelligence algorithms are used to correlate data and recommend adjustments. Automation is increasingly present, allowing the entire cycle to be optimized. However, it's important to consider challenges. The first issue that usually comes up is the cost of implementation. Equipping a building with all the necessary technology, LED lights, irrigation systems, state-of-the-art sensors, climate control infrastructure, and CO2 management requires a high initial investment. In addition, there are ongoing electricity expenses to keep everything running. On the other hand, many projects point out that over time, the efficiency generated by this form of cultivation offsets the initial outlay. Greater control over pests and production stability reduce losses and can balance the financial equation. Another challenge involves large-scale expansion. Although there are examples of vertical farms supplying supermarket chains, it is still not the predominant form of cultivation globally. To reach considerable production volumes, installations and logistical flow must be carefully planned. Additionally, each crop has different requirements, and some types of plants adapt better than others to the vertical environment. Leafy greens, herbs, and some fruits like strawberries tend to perform very well. On the other hand, grains or vegetables that require more space and natural light may demand complex adaptations. In terms of food security, vertical farms can represent a strategic component as they help mitigate the risk of shortages caused by adverse weather conditions or natural disasters. With the ability to produce year-round and in a predictable manner, locations facing challenges in food importation may find a partial solution in this type of cultivation. If combined with appropriate public policies, this model could be expanded to support densely populated areas where arable land is scarce. There are examples of companies that have specialized in this field, building systems in modular containers that can be quickly installed in parking lots, industrial areas, or even on rooftops. These containers are equipped with LED lighting, hydroponic systems, and climate control, allowing for year-round vegetable cultivation. In many cases, harvesting can take place several times a month, offering always fresh produce to restaurants, markets, and consumers. The fact that it's modular ensures that the installation can expand or be relocated according to demand, which is an advantage in large urban centers that are constantly evolving. Another interesting topic is the possibility of growing more exotic or specific plants that don't adapt well to the local climate. In a vertical farm, with full control over temperature, humidity, and nutrients, it becomes feasible to reproduce conditions from other regions of the planet. This opens up the opportunity to offer differentiated products that were previously imported. As a result, new markets and consumer niches that value fresh and exclusive items emerge. This type of diversification is also seen as attractive for those looking to venture into the field, as crop variety can make the business more flexible and profitable. The involvement of big data and artificial intelligence is another dimension that has been transforming these ventures into high-tech environments. By collecting data on each plant's growth, the amount of nutrients consumed, and the response to lighting types, algorithms can indicate the best time to irrigate, the most suitable light intensity, and even the exact moment to harvest. This way, decision-making moves beyond intuition and becomes based on analysis and predictive modeling. This reduces the risk of human error and increases productivity per square foot. There are vertical farms that report productivity statistics far superior to traditional farming methods, precisely due to this intensive monitoring. Even though the concept of vertical farms is not entirely new, there have been records of projects and studies since the last century. The relevance of this model grows in step with intensifying environmental and urban demands. The combination of population growth, the need for fresh food, and decreasing availability of water and fertile land drives the search for alternative solutions. Vertical farming is one of the most promising alternatives, as it adapts well to metropolitan areas, utilizes clean technologies, and can offer direct benefits for food security. That doesn't mean the road will be easy. High upfront costs, technological barriers, and a general lack of market knowledge still pose significant hurdles. However, as researchers, engineers, and investors join forces, it's likely that these limitations will be overcome and the solutions will become increasingly accessible. Some believe that, in the future, a large portion of vegetables and flowers cultivated in urban environments will come from these multi-level farms. This projection makes sense in places like Singapore, Japan, and even in European and North American cities, where space is limited, but demand for high-quality food is strong. One of the keys to expanding this model is making it economically viable. This includes, for example, reducing energy consumption. The use of increasingly efficient LED lights and smart climate control systems can help a lot. Integrated and automated management also lowers labor costs. In some cases, there are farms that operate with a small team, since many of the processes are mechanized or robotic. In these projects, labor tends to focus on equipment maintenance, harvesting, and monitoring performance indicators. Another aspect that could drive the adoption of vertical farms is growing awareness about the importance of a resilient food system, especially in times of climate uncertainty. Natural disasters, long droughts, or intense flooding can affect traditional crops, while these controlled environment facilities remain less vulnerable. This resilience is of interest to both governments and food sector companies that seek stable product supply. In a time marked by changing consumption habits in a pursuit of healthy eating, this model also resonates with consumers who care about quality and food origin. In terms of consumer health, the precise control over nutrient use and the near absence of chemical pesticides usually results in high-quality products, free from residues that could affect human health or the environment. This characteristic adds value and allows products grown in vertical farms to stand out in the market. Moreover, since they are harvested practically on the day they will be consumed, they better preserve their nutritional property. All of this fits into a trend of seeking fresher, traceable foods produced ethically and sustainably. Financial balance, however, still depends on factors such as energy costs, scalability, and market acceptance. In some regions, electricity is expensive, and vertical farms require substantial investments in lighting and cooling. However, as technologies evolve and system efficiency increases, the forecast is that these costs will drop. In addition, policies that encourage urban agriculture, energy subsidies for sustainable methods, or carbon credits could make this model competitive compared to traditional agriculture, especially in places where land and water are scarce resources. There is an interesting debate around adapting high-value crops, such as medicinal herbs and natural supplements, since these plants tend to have higher profit margins and require careful temperature and humidity control. Some companies see this area as a promising niche, as it allows for added value in the final product. The same logic can be applied to cut flowers for arrangement, which at certain times of the year can be expensive on the market and require strict logistics to avoid wilting. In a controlled environment, it is feasible to grow delicate species and deliver them almost immediately to local consumers, maintaining a high-quality standard. Lastly, the growth of vertical farms can also inspire innovations in other areas related to food production, such as algae cultivation or fish farming in aquaponic systems, in which tank water is reused to fertilize plants. These combinations create opportunities for synergy among various cultivation methods, maximizing resource use. Urban environment agriculture ceases to be a separate concept and becomes part of an integrated ecosystem, potentially offering solutions to multiple challenges at once: job creation, supply of fresh food, reduction of water footprint, and environmental impact. Therefore, when we talk about vertical farms, we are looking at a phenomenon that goes beyond simply stacking plant shelves. It is a model that combines principles of efficiency, sustainability, and innovation, rethinking the logic of where and how we produce food. If in the past the image of a farm was always associated with vast fields of crops, today we can include skyscrapers and tech warehouses as part of the option. This shift suggests that agriculture is becoming more flexible, resilient, and increasingly closer to the consumer. By combining controlled environment production with the growing demand for freshness and convenience, vertical farms show that there is room to reinvent the way we feed society.